Hello friends, good evening. This is Sooraj Gopi. I welcome you all to this live, very important class of engineering mechanics. As you all know, mechanical engineers, civil engineers, all can join to this session and you can have the practice of the top 60 questions for the gate examination perspective. Okay, so this is Sooraj Gopi. I welcome you all to this live and important practice session of engineering mechanics. Do let me know I'm audible, everything is perfect. Okay. Good evening, Shrikant. Good evening, Amritesh. Good evening. After a long time, I'm back on YouTube. So because I was having many classes on the paid course, so now I'm free for you guys. So we have started the crash course. So I thought let us boost up this crash course and let's go with the best last 30 to 40 days which you are having, because you know mechanical engineers are having this year like 2021 gate at the end of the session. So let's use that golden opportunity which all of you are having, and this is very effective for all mechanical and civil engineers. So if you are a civil or if you are a mechanical aspirants, do see this video till the end so that we are having a very top quality questions from engineering mechanics point of view, because this subject is so interesting. If you know the concept, you will be answering. If you don't know the concept, then you will be stuck out. So we need to solve some very quality questions so that you are not able to stuck in gate 2021. So my dear friends, yes, definitely I'll be adding the newly covered topics also, that is Lagrange and your second method, both your friction, we can say rolling friction, sliding friction, everything will be discussed in this sessions. That three parts are there, 20, 20, 20, 60 top questions will be discussing. Okay. So yes, good evening all, good evening. So let's start without wasting your time. Let's start with the session. Let me introduce myself. Those who are new to this session, let me introduce myself. My name is Sooraj Gopi. I have more than 5 years in teaching experience. I am dealing with these 5 subjects. Okay, let's boost up this preparation and let's start with a very unique and conceptual based problem from engineering mechanics point of view. Okay, and please do let me know if you're having any doubt. You can stop then and there itself. Okay, so ready guys? Yes or no? Ready? Yes or no? Please do respond, because then only I'll be going with the first question. 20 questions, 20 quality questions, 3 days, 7 o'clock. You need to be live with me. Okay, so let's start with very basic question. First question: a bar of uniform cross section and weighing 100 Newton is held horizontally using two massless and inextensible string S1 and S2. You have to tell me what is the tension in the two strings. Okay, so quickly, yes, Gaurav, already covered. I need a response and you need to be active in these sessions, because this is like last effort, last push you need to give, because this last push will be changing your rank with a very huge margin. Okay, so let's start. So first question, you have to calculate T1 and T2 such that this rod will be in a horizontal position. So how to calculate, sir? Very basic. You first of all identify number of forces acting on this rod. Okay, so we are having this rod, rod which is horizontal. So at the center point we'll be having a weight acting like this, and we'll be having two tensions. One is this is T2 and this is T1. This is the free body diagram. So definitely we can say T1 plus T2 is equal to weight, that is equal to 100 Newton. Okay, let's suppose this is point A and this is point B. Let us calculate moment about point A. Moment about point A, make it equal to 0. So tell me, what is the moment due to this T1 force? What is the moment due to this T1 force? It is definitely equal to 0, and T2 will be making a moment. This is T2 into L by 2 is equal to W into L by 2. So T2 is equal to W directly. That means T1 is equal to 0. So we can say T1 equal to 0, T2 equal to 100. Option B. Very good. Anirudh, correct answer. Very good. Okay, so you need to be quick. Take a pen and paper, because these will be practice sessions for next 3 days. 20 questions each day will be practicing. Okay, this was a previous year question. I felt starting will be previous year question, then we'll be having some increasing level of the problem. Okay, next question. Very important and very interesting problem. A 30 kg block B below is suspended by a 2-meter cord attached to a 60 kg cart. Friction is negligible. The system is released from rest in this position. Calculate the ratio of the magnitude VA by VB when the cord is vertical. When the cord is vertical, that means initially the cord was like this, you just had a movement or you just had a motion, so definitely this cord will be moving in the back side. So you have to tell me what is the ratio of the magnitude of VA by VB. Quickly. It's very easy, very easy. Let me give you a hint. You have to use momentum conservation. Okay, just apply law of conservation of momentum and you'll be getting the answer. Let me give you a hint. Law of conservation of momentum. Now tell me, if this A block is moving in the forward direction, let us say with velocity A, tell me what will be the direction of velocity B? Back side, left side or right side? What will be the direction of the velocity of block B? Right or left? Do tell me that. Right or left? Definitely it will be on the back side. Okay, so we can say mass into velocity of A plus mass of B into velocity of B into negative sign because it's in the opposite direction, that should be equal to, it is released from the rest, so definitely it will be equal to 0 because there is no velocity at the initial condition. So final momentum should be equal to initial momentum. So from this we can calculate MA into VA minus MB into VB equal to 0. So from this we can calculate VA by VB is equal to MB by MA. Tell me what is the correct answer for this. Option A, B, C or D. MA is 60. So this is 60 by 30. Fine, 60 by 30. MB is, okay, MB is 30, not 60. 30 by 60. Okay, it is 30 by 60, though that is equal to 1 by 2, not B. Please cross check the answer. That will be option A. Option A, Neeraj. What is MB? Mass of block B is 30 kg. Mass of block B is 30 kg. Mass of block A is 60 kg. That will be 30 by 60. That is equal to 1 by 2. Simple question. Is this clear? Very easy question. You just need to apply the law of conservation of momentum. That's it. Okay, you have to apply law of conservation of momentum because this block was released from, the system is released from rest, so definitely initial velocity will be equal to 0, and after the motion, when the body is in motion, definitely it will be having some velocity V and VB. Okay, so directly just we have applied the law of conservation of momentum and we have got the final result. Option A is the correct answer. Okay, is this clear? Very important logical. These type of question we'll be discussing for the next 18 problem will be something like this. Okay, in which concept will be used. Okay, because engineering mechanics is that subject in which if you know the concept you can answer it. If you don't know the concept, then it's very difficult for you to answer the question. Next problem, let's see who will be answering. It's a very easy question. This type of question, they are usually asking for 1 marks in GATE examination. If point A is in equilibrium under the action of the applied forces, what are the values of the tension TAB and TAC respectively? Let's see who will be responding quickly and efficiently. And before answering, please do give a like to this session because I'm seeing the students are live. Still they have not yet given a like to this session. Okay, yes. Anindya, okay, fine. Quickly, what is the answer? Let me give you a hint. Use Lami's theorem to solve this problem. Okay, you can use Lami's theorem, you can use method of resolution to solve this problem. Okay, let me use Lami's theorem. Can you tell me what will be this angle? Angle A. If this is 30, this is 60, so this will be 90. So we can say 600 by sine of 90 is equal to TAB by sine of the opposite angle is 120 is equal to TAC by opposite angle is 60 plus 150. 60 plus 90 is 150. Sine 150. Okay. Very good. Very good. Neeraj, Ajay, very good. Correct. Correct answer. Just calculate one value because all that are distinct value. So if you are able to calculate only one, just let us take this combination. So sine 90 is 1. So TAB is equal to 600 into sine 120, that is sine 90 plus 30, that is cos 30. So 600 into cos 30, that is root 3 by 2, root 3 by 2. So approximately you will be getting 520 Newton. Very good. Okay, so by elimination all the options has been eliminated, so option is the correct one, but still we are having the time for the practice. Let us try to calculate TAC also. So TAC will be equal to 600 sine 150, so it will be 600 into cos 60, that is equal to 1 by 2, that is 300 Newton. So now we are pretty sure option A is the correct answer. Now you are pretty sure option A is the correct answer. Is this clear? Very easy question, Lami's theorem. And my dear friend, if you are preparing for GATE exam, and if one question definitely, if I can say from engineering mechanics, you will be getting from Lami's theorem. Okay, so make sure you are practicing a lot of questions from the Lami's theorem. Okay, next question. Okay, a disc of mass 14 kg and radius 1 meter is attached to a spring which is having stiffness of 75 Newton per meter, and it's unstretched. What is the meaning of unstretched? That means you are not stretching the spring. Unstretched length is 1 meter. If the disc is released from rest in the position as shown in the figure, okay, that means you are elongating and you're releasing it. So you have to tell me what will be the angular velocity at the instant when the center of mass is displaced by 3 meter. Got the question? You have to tell me what is the angular velocity of this mass, because definitely this is a disc. This is a disc. Okay, so you have to tell me if this is a disc, initially it was somewhere around this. Okay, it was something like this. So when you pull it and you will release it, definitely it will be rolling like this, and they are already discussing the disc is rolling without slipping about its center. Okay, so how to calculate? Yes, anyone? How to calculate this type of problem when you are getting this type of questions, and these are very important and concept based problem. Any idea, any theorem or any law which you will be applying to this? I can give you one hint. Please use energy of conservation or conservation of energy. You'll be getting the answer. Let's apply conservation of energy and let's try to solve this question. Okay, so apply the conservation of energy. Conservation of energy. Exactly. Very good, Anandita. Conservation of energy. So first of all, tell me, when you are placing this disc at this position, can you tell me what is the deflection in the spring? Let's say that is x1, that is at the initial point. Can you tell me what will be the initial deflection? Unreleased length is 1 meter. So at this moment, this is the total length. So I can say, can you tell me what will be this length? If this is 4, this is 3, what will be this length? This will be 5 meter. 4 square plus 3 square under root of this, that will be 16 plus 9, 25, that is 5 meter. So I can say 5 minus 1, that is your deflection in the spring, 4 meter, because 1 meter is the unstretched length. If I calculate what is the final deflection in the spring when the mass or when this disc is exactly located over here, in this case deflection is 4, so we'll be having 4 plus 1, that is equal to 3 meter. So we got deflections 2 times, one initially and second final. Okay, so at the initial position we are not having any angular velocity, and definitely when the mass will be rolling, when it locates at exactly vertical position, it will be having some angular velocity. So I can say the initial energy of the system, can I write it like this, half k xi square, nothing else. Okay, and what will be the final energy? That will be half k xf square plus half I omega square. Equate this and get the answer. As simple as that. Use conservation of energy. Use law of conservation of energy. Law of conservation of energy, law of conservation of energy. That means the total initial energy should be equal to total final energy. Initial energy is half k into xi square. Final energy is half k into xf square plus half I omega square. Now, tell me what will be the mass moment of inertia for this particular. What is the mass moment of inertia of the disk about the center? Because this disk is rotating about its CG. This disk is rotating about its CG. So tell me what will be the value of I? What will be the value of I? Anyone? And these are very important. Surely you will be getting some questions like this for 2 marks in GATE examination. So we know that mass moment of inertia is mr square by 2. Okay, so let's place every value and let's try to solve this. Xi is 4, so this is half into k value is given as 75. So it is 75 into 4 square is equal to half into 75 into this is 3 square plus half into mr square by 2 into omega square. Omega you need to calculate. So by solving this, radius is already given, that is equal to 1 meter. Mass is 14 kg. Apply the concept and get the answer. Mass is 14 kg and radius is equal to 1 meter. Apply this and tell me what is the value of omega you are getting. Only pure calculations is left out. So we are having half into 75 into 16 minus 9, okay, into 4 divided by 14 into 1 square. After solving it, tell me what's the value you are getting. Please check, you will be getting approximately 8.66 as the correct answer. 5 root 2. You will be getting 5 root 2 as the correct answer. Very, very easy. We are assuming half I omega square. This is your rotation energy. Sir, we didn't consider energy due to translation. No, my dear friend. Why? Because if this body is rolling, definitely what is happening, this spring is being compressed like this. Okay, so at each and every point what is happening, there's a compression of the spring is happening. So technically there would definitely will be energy which is we can say nullifying that. Okay, simple words I can say, initially when you are pulling it will be having some potential energy. So when you release it, this body will be, this spring will be compressing, okay, and this body will be rotating. Okay, definitely you will be asking, sir, can we use half mv square? Definitely you have to use that also. Definitely you have to use half mv square. You have to use half mv square also. Definitely you have to use half mv square. Very good, because your final energy definitely will be having the combination of rotation plus kinetic. This is your rotation energy, this is your kinetic energy, and so when you add, this will be 1 by 2 m r omega square. So what is this? This is 4, this will be 4 plus 1, 5 by 2. This will be 5 by 2. Please try to solve it. You will be getting the correct answer. Fine, it won't be 8.6, it will be approximately 10.5. Please do check. I'm not having the exact value. Please do check the values. You will be adding kinetic energy and your rotation energy. Definitely. You will be adding this also. Very good. Half mv square. Okay, convert rotation into linear part and you'll be getting the answer. Okay, is this clear? Fine. Lavesh, clear hai? Okay, because ultimately what we have to calculate, we have to calculate omega. Right? Done. So we'll be having 5 by we'll be having 3 by 4. You'll be having 3 by 4. So this will be we can say 3 by 4 mr square omega square is equal to half into 75 into 16 minus 9. Clear? Mass is 14 kg, so we'll be getting omega square is equal to half into 75 into 16 minus 9 is yours 7 into 4 by 3 into 1 by 14. Under root of this will be your answer. Okay. This question you can expect for 2 marks in the GATE examination. This question you can expect for 2 marks in the GATE examination. Okay, chaliye, please try to solve it. Calculation part I am giving to you. You can solve it and you can tell me the final answer, because I'll be giving you some homework also. I'll be giving you some homeworks also, so that you are practicing the engineering mechanics topic. Okay, clear? Okay, next question. It's a very easy problem. This was asked for 1 marks in the GATE examination. This kind of question was asked for 1 marks. The question is, a flywheel of moment of inertia is 5 kg meter square. It is rotated at a speed of, that means your moment of inertia is given 5 kg meter square. It is rotated at a speed omega is equal to 60 radian per second. Because of the friction at the axle, it comes to rest in 5 minutes. It comes to rest in 5 minutes. Calculate the total work done by the friction. Now, what is the meaning of total work done? I can say the total work done will be the change in kinetic energy. I can say the total work done is equal to change in kinetic energy. So, if I am able to calculate the change in kinetic energy, I will be getting the final result. Okay. So, calculate the change in kinetic energy, because final velocity equal to 0. Directly I can say half I omega square. From this I will be getting the answer. I is given 5, omega is given 60. Directly you need to answer and tell me the correct value. So we'll be having half into 5 into 60 square. So tell me what's the value. So this will be 5 into 30 into 60. So this is 180 in kilojoule. You have to calculate in kilojoule. Yes, anyone who has calculated? 15 into 6, 9 kilojoule. You will be getting 9 kilojoule as the correct answer. Simple logic. If any question they are asking you work done, you have to calculate change in kinetic energy. That's it. And final velocity is equal to 0. It is coming to rest. So omega 2 will be equal to 0. Fine. Initially the velocity is 60 radian per second. Final velocity is equal to 0. So directly I can use half I omega square. I'll be getting the value. Okay. Change in kinetic energy. Clear? Any doubt in this? All good? Are you able to understand the logic behind these problems? Because we'll be having variety of questions from every topic of engineering mechanics. Okay. Chaliye, next. Let's see who will be responding to this problem. It's a pure technical concept base. A body is in pure rotation. The linear speed v of a particle, the distance r of the particle from the axis of rotation, and angular velocity omega of the body are related as v is equal to r into omega. This is given in the problem. Then you have to tell me which of the following statement is correct. Omega is inversely proportional to r. Omega is directly proportional to r. Omega equal to 0. Omega is independent of r. Simple question, very logic based. Tell me, if a body is undergoing pure rotation, so you have to tell me which of the option is correct. Yes, Dharmesh, Vinod, Lavesh, Anindya, Ajay. Yes, Praveen, quickly. What is the correct option for this? Let's see who has concept clarity about pure rotation. Sir, let us suppose if there is a link, okay, let us suppose there is a link which is rotating with some omega, okay, and this is point A, this is point B. If you move away from the point of hinge point, this is the hinge point. If I say, let us suppose I am taking a point B dash, let us suppose I am taking a point B dash, what is the omega or at point B dash? My dear friend, this whole link will be rotating with the same omega. Angular velocity is never ever dependent on r. Angular velocity is never dependent on r, so definitely option D is the correct answer. Each point of the link will be having same angular velocity. Remember, let us suppose if I say, let us suppose if I say there is a link, okay, fine, and it is rotating with some angular velocity omega, and this is a point 1, this is point 2, this is point 3, and this is point 4. So at each and every point we'll be having same angular velocity, only difference will be the tangential velocity, linear velocity. V1 will be equal to R1 into omega, V2 will be equal to R2 into omega, V3 will be equal to R3 into omega. That means your tangential velocity will be depending on the radius. Okay, angular velocity is always independent of the radius. So option D is the correct answer. Is this clear? All good? Perfect? Bounce तो नहीं मार रहा, बता दीजिए, please do tell me. All good? Because these type of questions अगर आप practice करोगे, if you're practicing this level of question, definitely never ever you will be stuck in any problem in engineering mechanics. Okay, the main intention of conducting this session is you should be having the concept clarity and you should be having much understanding about this subject of engineering mechanics. Let's see who will be answering to this problem. A weight of 20 Newton falls from a height of 200 mm on a rigid massless bar supported by two identical springs as shown in figure. If the maximum deflection of the spring is 10 mm, then the stiffness of the spring is. Let's see who will be responding to this question. Very easy question. 3 to 4 question. Engineering mechanics is basically that subject. We usually say if you are watching your football matches, in every league, in every group, there will be one team which we say it's like underdog. Okay, so we can say engineering mechanics is an underdog subject. Sometimes you'll be having very unique question, very problematic question, nowhere no students is able to solve. Sometimes we're getting very direct formula based question. Okay, so we can say it's an underdog subject, so don't underestimate this engineering mechanics. So it's a very, very important. Okay, parallel connection. Okay, so how to solve? Let us suppose the maximum deflection is delta. So from this point the maximum deflection is delta. So can I say, if I equate the energy conservation, if I use the energy conservation, that will be very helpful for us. Initially I can say the decrease in the potential energy of spring should be equal to the we can say the strain energy or the stress energy in the stress or strain energy stored in the spring. Okay, what is the potential energy when you are dropping a 20 Newton body? So definitely from a height of 20 meter, it will be having some potential energy at this point. So let us suppose that is equal to m into g into 200 plus delta. What is this delta? That is equal to 10 mm. That is equal to 10 mm. Okay, that is equal to 10 mm. So I can write this as 10. And this should be equal to half into k into delta square, because your spring is being compressed by delta. Equate this value, get the value of k, and this will be into 2. Why? Because two spring has been used, so we will be multiplying by 2. So now you will be getting the answer for this. Let's see. Parth, sir, I'm not able to, YouTube is playing properly. Let me check from my side also. And this will be into 2. It's all good, my dear friend. Quickly solve. Mass is given 20. So this is 20. Let us take G is equal to 10. This is 210. This is equal to half into K value is, you have to calculate. This is 10 square into 2. So you have to calculate the spring stiffness. Calculate and tell me what is the value you are getting. Please do some calculation. You all are GATE aspirants. You all will be the rank holders of GATE examination. So make sure you all are using your calculators so that you are quickly solving the problem. So this 10 cancel out, this 10 cancel out. So we are having 4 to 0, right? Oh, this 10 is not required because already is given in G. It's already given in Newton. Okay, it's not kg, it's already given in Newton, so directly it will be 42 Newton per mm. 42 Newton per mm. Option B. Option B. Already it's not mass, it's weight given, that is 20 Newton. So it will be 42 Newton per mm. Easy question. Only what we have did is the energy stored in the spring due to that drop in potential energy, of mass is equal to the stress or the energy stored in the spring. I can say directly in easiest way, energy stored in the spring will be equal to the decrease in the potential energy. Law of conservation of energy. Okay, many question you are expecting from the law of conservation of energy, so make sure you all are practicing these type of questions as of law of conservation of energy. So 42 Newton per mm is the correct answer. Let's proceed. Any doubt till this point? All good, all perfect, all going good, able to visualize, able to understand what kind of question you can expect in the your mechanics. Only 7 questions we have solved. Still half kx square energy, potential energy in the spring, the decrease in the energy due to that height will be equal to the increase in the energy of the spring. Okay, because energy can neither be created nor be destroyed, it will be going from one point to another point. Okay, chaliye. A coin is placed on a rotating table, just slips when it is placed at a distance of 4 centimeter from the center. So basically there is a turntable, this is a table, and a coin is being kept at a distance of 4 centimeter from the center of the table. Okay, if the angular velocity of the turntable is now doubled, at what distance from the center it will just slip? That means you have to calculate at what radial distance from the center the coin will be experiencing the slipping. So first of all, tell me which force is responsible to move this coin radially? Can anyone tell me which force is responsible for moving this coin in the radial direction? Which force is responsible? Let us suppose this is a coin which is rotating like this. So can you tell me which force is moving this coin away from the center? Which force? Centrifugal force. If you remember the concept of rotation body, when a body is rotating with some angular velocity, this body will be experiencing some centrifugal force. So definitely, if I say your centrifugal force, if your centrifugal force is greater than equal to your friction force, then only this coin will be slipping. So I can say for slipping of coin, the centrifugal force should be greater than equal to friction force. So I can say mr omega square should be greater than equal to mu into mg, where m is the mass of the coin. So ultimately I can say the minimum radius required should be equal to mu g by omega square. Minimum radius required, that means minimum position of that coin at which it will be experiencing the centrifugal force will be more than that of the friction force. The coin will be experiencing the slipping condition, that will be mu g by omega square. Mu is constant, g is constant, so I can say the minimum radius is inversely proportional to omega square. Minimum radius is inversely proportional to omega square. Okay, now what you have did, you have doubled the omega. What you are doing, you are doubling the angular velocity, that means r minimum or r2 by r1 is equal to omega 1 by omega 2 whole square. Okay, so what is omega 1? Let's say that is omega, that is 2 omega whole square. So I can say r2 will be equal to r1 by 4. What is r1? That is equal to 4 centimeters. So this will be equal to 1 centimeter. That means when you are doubling the angular velocity, if you keep the coin exactly at 1 centimeter, this coin will be undergoing a slip. Is this clear? So I have not used any we can say big formulas. I've just used the basic concept to answer this problem. Okay, this is a very unique question. I felt this should be discussed with you. So this kind of unique questions will be discussed for the next 3 days, 60 questions in total, 20 each. Okay, And my dear friend, this is only the 8th question. Still 12 questions are left. So please boost up, please energize yourself. For the next 40-45 minutes, we'll be having the session. Okay, next problem. Easy question. It's a very easy question. Again, I told you, you have to use Lami's theorem. A weight of 500 Newton is supported by two metallic ropes as shown in figure. The values of tension T1 and T2 are respectively. Easy question. Let's see who will be replying to this problem quickly. Lavesh, Giraj, Parth, Neeraj, Raman. Quickly. I need quick response from you, from all of you, and please do hit a like before please like this session along with answering to this problem. Let's see who will be answering, and let me check who is the first one to reply it correctly. So again, let me directly go for exactly. No, it's not on Gradeup app, it's on YouTube. It's on YouTube only, my dear friend. So let me use Lami's theorem. 500 by sine 90 is equal to T1 divided by sine 120 is equal to T2 by, now I don't know what is this angle. Can anyone tell me what is this angle? 90 plus 120, that is equal to 210. So this will be sine 150. Sine 150. So directly we can say T1 is equal to 500 sine 120 and T2 is equal to 500 sine 150. Very good, very good. Neeraj has already responded. Karthik is responding, going with B. Anyone else who want to respond? What is sine 120? That is cos 30. Cos 30 is root 3 by 2. Or cos 60 is 1 by 2. So this will be 250. 250 Newton. So option B and D is being eliminated. So this is 500 into root 3 by 2, that is equal to 250 into root 3, that means 1.7. So approximately it will be 433, I suppose. Option A. Because T2 value is 250. We are getting T2 is equal to 250, my dear friend. Sine cos 60 is 1 by 2. Cos 60 is 1 by 2. That will be 250. So directly we have eliminated option B and D. Dinesh, Abhishek, I hope so you got the point. B and D is not possible. Clear? Option A is the correct answer. Clear? All good? Done. देखो यार, it's very easy. Only apply Lami's theorem. Only apply Lami's theorem and get the answer. Only calculation part is left. Chaliye, next. Let's see who will be answering this question. Two forces of magnitude F are acting on a uniform disk rolling without slip on a horizontal surface. Okay, as shown in this figure. Very good, Sonali. Very good, Dev. Very good, Abhishek. Then Dinesh. Very good. Correct. Next question. Two forces of magnitude F are acting on a uniform disk rolling without slip on the horizontal rough surface as shown in this figure. Friction force on the disk is N times F. So you have to tell me what is the value of F. Okay, the question is, there's a friction force which is acting, okay, and this is rolling without slipping. You have to tell me what will be the value of this friction force in terms of F. Like it's 5 time F or 2 time F or 1.5 time F or 0 time F. Let's see. Okay, Abhishek has already responded. Option D. Anyone else? Very basic. I can first of all calculate the free body diagram. 2F minus F is equal to M into A. The body is moving in the forward direction with some acceleration A. So definitely 2F minus F is equal to MA. Okay, if I calculate with respect to the rotational perspective, so F plus small f into R is equal to I into alpha. Okay, F plus F into R is equal to I into alpha. I'm getting mix of answers. I'm getting A, B, C and D. I'm getting all the 4 options, my dear friend. It's an MCQ. Let's see. and A is equal to R into alpha. Okay, fine. So let's do one thing. Let's put this value of A over here. So I can say this is 2F minus F is equal to M into R into alpha. And this will be F plus F into R is equal to I. What is the mass moment of inertia about its CG? Because it is rotating about its center. What is the mass moment of inertia about its center of gravity of a disk? It is equal to mr square. So this will be mr square by 2 into alpha. Solve this equation and tell me what is the F value you are getting. Solve this equation and quickly tell me what is the value of F you guys are getting. So multiplied by 2, so you are having 2F plus 2 small f into R, that will be cancelling out, that is equal to mr into alpha. So equation 1, equation 2, calculate, solve it, so we'll be having 2F plus 2 small f is equal to 2 capital F minus f. This will be cancelling out. What is the value of you're getting? That is equal to 0. That means if a body is rolling without slip and if you're applying a force at the CG as well as at the end point, the frictional force will be exactly equal to 0. We'll be having 0 frictional force acting on this body. Option D is the correct answer. You'll be having exactly 0 frictional force. Okay, is this clear? Let me hide my screen so that you are able to see this solution. It's a very easy one. Only thing is you need to apply the concept. You need to apply the concept. That's it. All good? Clear? Are you understanding the questions? Because these type of question you can expect in GATE examination. That could be for civil, that could be for mechanical, or that could be for chemical. Okay, any branch, if engineering mechanics is there, you can get this level of question in your examination. No slip means no friction. No, my dear friend, no slip means at this point will be having no force acting at the point of contact. If I say a body is rolling without slip, that means definitely there is a friction in the system. If a body is slipping, that means there is no friction. As simple as that. Okay, chaliye. Next question. Easy one. Free body diagram. It's only if there is friction, then only you will be having no slip condition. If there is no friction, then definitely the body won't be rolling, it will be slipping continuously. Okay. Consider the situation as shown in the figure. The wall and the surface of the contact between A and B are rough. The friction on B due to A in equilibrium. What is the direction of friction on B due to A? What is the direction of friction on B due to A? Simple hai? Simple. Okay. Now if we draw the free body diagram of mass A, this is not a compound chart, these are two masses. Okay, chaliye. So draw the free body diagram. There will be having one normal reaction, will be having one MA into G, will be having a normal reaction due to this block, that is N dash, and definitely will be having a friction force in the upward direction opposite to the MG. Okay, if I draw the free body diagram for mass B, will be having N1 from mass A. Okay, will be having M B G, will be having a force F. Now tell me where will be the friction force? Definitely opposite to this force. So this will be a friction F dash F1. So it will be in the A, B, C, D. In which direction? In which direction will be having friction force, my dear friend? It will be in the upward direction, option A. Simple. Draw the free body diagram, that's it. Draw the free body. In this problem, we will be having an F1 in this direction, that is in this. So the friction on B due to A will be in the upward direction. Definitely, it won't be in the downward direction, because if you see on B, there are only 4 forces, all are acting orthogonally. So friction force will always be acting to the direction of the motion, and mg is pulling the body in the downward direction. Definitely there will be a friction force, and it's very quite obvious. If there is a mass B, if you try to pull this downward, so definitely the friction will be acting in the upward direction. Okay, option A. Very good, Rishabh, Abhishek, Dinesh, absolutely correct. Sonali, very good. Option A. Next, there's a question from the truss topic, and these questions they are frequently asking. There's a pin jointed cantilever truss shown in this figure. Repeats our explanation. Yeah, definitely. Free body diagram for point A. A normal reaction from the fixed joint, that is N. There is a mass mg. Okay, there is an N1, and definitely between A and B we're having a friction force. So we'll be having one friction force between A and B in upward direction, and here we'll be having the downward direction. Why? Because this body B is trying to pull this body in the upward direction. It's as simple. If this body A, this is body B, if I try to apply a force, this body B is trying to stop this body A to move in the downward direction. Is this clear? Is this clear? Fine. So if you talk about body B, when you place this value, this body has a tendency to move downward. So definitely the direction of friction will be in the opposite direction. So that is why option A. Next, very important. This from the truss topic. A pin jointed cantilever truss is loaded as shown in the figure. What is the force in the member of ED? That means this member. What is the force in this member ED? Easy question hai. Easy question hai. Try to apply the logic, you'll be getting the answer. Let us take point D, or let us take point C. Let us take point C. Okay, if you take point C, we're having FCD. Yes, definitely, Khan. Definitely, it's not having any biasing. Knowledge is basically you get from any point. You just take the knowledge, enhance your skill. That's it. You need to enhance your skill. You are from India or any other country, it doesn't matter. Ultimately, the main and important thing is knowledge. You need to improve your knowledge. You need to enhance your knowledge in order to compete, because competition level is very high nowadays. Okay, clear? So can you tell me what will be this angle? Anyone who can tell me? Dharmi is saying option C. He's saying 0. Okay. Can anyone tell me what will be this angle? This is 4. This is 4. So can I say this is 45 degree? If this angle is this distance is BD is 4, CD is also 4. So this will be 45. So this is, my dear friend, 45. So let us calculate FCD plus FBC cos 45 equal to 0, and I can say FBC sin 45 is equal to 80. Fine. So can I say FCD is equal to minus 80? FCD equal to minus 80. And my dear friend, if I calculate the free body diagram from point D, at point D we'll be having this and this. This is FCD, this is FED, and this is FBD, and FBD will be your 0 because there is no force to balance. So FED will be exactly equal to FCD. So option A is the correct answer. 0 is basically FBD. Okay, FBD is the 0 force. Is this clear? Fine. And one more thing I would like to announce to you, those who are attending these sessions, all PDFs will be given to you in our official Telegram channel of mechanical group. There's a Gradeup mechanical Telegram channel where you will be finding every day any faculty who has taught you any subject. The classroom PDF, this solution will be with you. Okay, so make sure all of you are joining with this Telegram channel, which you are getting in the pinned link in the comment box, and you will be getting this in the form of PDF. So option A is the correct answer. And please hit a like for this question, and let's proceed for the next question. Option ha. Let's see who will be responding to this very interesting question. A particle is thrown vertically upwards with initial velocity u. The velocity time graph for the motion of the particle considering upward motion as positive can be represented as. That means if a body is moving in the upward direction, you have to tell me, and that is considered as a positive. You have to tell me which is the correct representation of velocity and time. On the y-axis we are having time, and on the x-axis we'll be having your velocity. Simple logic based concept. Simple logic based concept. Okay, quickly. Option C. Okay, Neeraj is going with option C. Anyone else? Dharni is also going with option C. It's pure concept question. If you know the concept, you will definitely answer it. Anurag is also going with option C. Sunita is going with option B. Abhishek with option C. Okay, first of all, tell me what is the initial velocity of the body? What is the initial velocity of the body? Sir, initial velocity is a finite value and it is equal to u. So definitely at time t equal to 0, both graph are showing us 0 velocity. So A and C is not possible. A and C is technically not possible because at time t equal to 0, the velocity is showing 0. Okay, fine. Let's talk about B and D. Now, when it reaches the highest point, let us suppose you are throwing a body which is reaching a highest point. Okay, your velocity coming to be 0. So definitely there will be a time at which it will be 0. And we have stated upward velocity is positive. So it will be coming downward. So definitely for the next half, you'll be having negative velocity. For the first half, we'll be having the positive velocity. So where we're having the first half negative and second half positive? Here we're having first half is positive, second half is negative. Option D. Exactly. If you consider in the question what they have stated is upward velocity is positive and you're throwing a body in the upward direction vertically upwards. Okay, so from 0 to the maximum height you'll be having positive velocity, and from maximum height when it reaches to the ground you'll be having the negative velocity. So according to this statement, your option D is the correct answer according to this statement. Okay, and hit a like for this problem, my dear friends. It's a very good question. Okay, this is a very good question from your very basic. I have not used any formulas, only pure concept we have used. Clear? Fine. Next question kare. Let's proceed for the next question. Yes or no? Please be energetic, my dear friend. These sessions are very helpful for all of you so that you can implement your concept to the questions. Okay, next. If the rotating mass of the rim type flywheel is distributed on another rim type flywheel having mean radius is half of the mean radius of the former, then energy stored in the later at the same speed will be. It's something like a tongue twister. If a rotating mass of a rim, okay, so we're having two cases. This is case 1, case 2. Case 1 is having, let us suppose this is radius r. Case 2 is having half of the mean radius, that means r by 2. Okay, that means r2 is equal to r by 2. So you have to calculate what is the ratio of the energy stored at the same speed. So they are basically asking you E2 is equal to how much times of E1. That's it. E2 is equal to how much times of E1. That's the question they are asking. Let's see who will be responding. What is energy, my dear friend? Half I omega square. That is the formula. Okay, I know, sir, energy is equal to half I omega square. E is equal to half I omega square. Let's take the ratio and let's see what is they are asking. That is half I omega square, half I 1 omega square. This is 2. Omega is same speed. So this will be cancelling out. Half cancelled out. So you're having E2 by E1 is equal to I2 by I1. I2 by I1. What is the mass moment of inertia of a rim? That is equal to mr square. Okay, mr square. Now radius is being halved. So what is the answer? My dear friend, A, B, C, D. Now you should be getting the correct answer. This is m r2 square by m r1 square. Mass and mass cancelled out. Out is equal to r by 4. So we are basically getting E2 is equal to E1 by 4. That means is 1/4 of the first one. I think no one. Okay, Sonali has responded. Vardhaman, very good. Vardhaman, Rajan, very good. Correct. Option D is the correct answer. It's very easy. Nothing. I just use basic energy formulation. That's it. Half I omega square. Is this clear? I've just used half I omega square. That's it. Neeraj, correct. It is 1/4 of the first one. Option D. Read the statement. They are asking how much times of E1 the energy has been reduced or increased. Very good, Sunita. Absolutely correct. Chaliye, let's proceed for the next question. Let's proceed for the next question and see who will be responding to this very important question. A smooth sphere, that means what is the meaning of smooth? No friction. Having a weight of 300 Newton is resting against a smooth wall figure. The reaction at the support A will be. Chaliye, jaldi, jaldi, quickly, I want quick response from all of you. What will be the reaction at point A? So let me draw the reaction forces to make you much more easy to understand. So this is your reaction force. Reaction is always perpendicular to the surface. So this is your reaction force. So let me draw a line like this, and if I draw like this is 60, this will be 30. As simple. This is 60. So this will be 30 because it will be making a perpendicular. So, and there is a weight. Any similarity, any theorem where you can use to get the value of Ra? Remember any theorem? Just tell me the name of the theorem. I'll be helping you out for that. There is a W acting in the downward. There is a RA acting, RB acting having an angle of 30 degree, and there is an RA acting like this. Which theorem you have to use to get the value of Ra? Simple, use again Lami's theorem. Okay, again use Lami's theorem to get the answer. So W by, now you have to calculate the angle also. Okay, so this is 120. Very good, Vardhaman, Electro, Gaurav, very good. So W by sine 120 is equal to Ra by sine, not 120, this will be 150, right? This is 150. 150, it's not 120. W by sine 150 is equal to sine 120. So your Ra is equal to, W is 300 divided by sine 150 into sine 120. Tell me what is the answer? What is the answer for this? Sine 150 is cos 60, sine 120 is cos 30. So ultimately what you are getting is 300 by cos 60 into cos 30. So approximate, tell me what's the answer you're getting. So you'll be getting 300 by cos 60 is 1 by 2 into cos 30 is root 3 by 2. This 2 and 2 gets cancelled. This is 300 root 3. So you're getting 300 root 3. Yes. Very good. 519.78 approximate. So 520 Newton is the correct answer. Okay. Absolutely correct. Option C is the correct answer. Vardhaman, absolutely correct. Very good. Okay. So the question was, they are basically asked the question from different perspective, and you can use Lami's theorem in that. Very easy. Okay. Ultimately, by the end of the day, you are again using the Lami's theorem wherever you are having 3-4 system. My dear friend, whenever you will be getting 3-4s, without any hesitation, you should be using the Lami's theorem. Okay. So 520 Newton, absolutely correct. Option C. Let's proceed for the next question. Okay. Very easy problem. Without solving, we'll be getting the answer. Without even solving, we can get the answer. They're asking, what is the force in the member of BE? What is the force in the member of BE? Option A, option B, option C, or option D? Quickly. Correct, correct. Very good, very good. What is the force in the member BE? So if you see at point E, we're having this as AE, FAE. Let me write, this is point E, this is FEA, this is FED. I'm just only drawing this for your reference, BE, and this is this is 60. Tell me, A, B, C, D. My dear friend, B is equal to 60, and that is a positive. Option B. Very good, very good. I told you, without solving, we can solve some very unique problem from engineering mechanics. This is an underdog subject, my dear friend. Engineering mechanics, sometimes the question level is so high, I can even bet some faculties will not be able to solve that question. That I can surely guarantee you. Sometimes the question level is so good, even the 100% students are lefting out that problem. Okay, so make sure you are getting the clarity of the concept and you are improving your concept from these 60 questions which we'll be discussing. Okay, next problem. Easy question, very easy question. Okay, so you have to calculate what is the tension in the member of QR. What is the tension in the member of QR? Let's see who will be responding it quickly. Okay, so when you take point P, quickly take point P. So on point P we're having F. Here we're having F. What's the point? This is Q. F PQ, and this is F PR, and this angle is 45, and this angle is 30. Okay, it's not 30, it's 60. It's 60. Okay, 60 degree. Quickly, you have to calculate FQR. So ultimately, if you calculate the value of FPQ, you will be getting the value of FQR. Fine. So I can say F plus FPQ cos 45 plus FPR cos 60 is equal to 0. Okay, one equation. Cos 45 is 1 by root 2. So this is F plus FPQ. Yes, you can use Lami's theorem, but I would rather prefer in this particular problem as your PR is equal to 2. Next is horizontal force FPQ. FPQ sine 45 is equal to FPR sine 60. So FPR is equal to FPQ into 1 upon root 2 into 2 by root 3. Okay, so I can say this is, let me hide my screen. So this is FPQ divided 2 FPQ by root 6. Fine. Place the value of FPR in this particular equation. So what we'll be getting, F plus FPQ by root 2 plus 2 by root 6 of FPQ is equal to 0. So from this I am getting FPQ is equal to minus F into root 12 divided by root 6 plus 2 root 2. Okay, fine. And from this, can I calculate, this is FPQ, this is FQR. FPQ cos 45 is plus FPR or QR is equal to 0. So FPQ is 1 upon root 2. So ultimately you will be getting FQR is equal to F root 12 divided by root 6 plus 2 root 2 into 1 upon root 2. Into 1 upon root 2. That's it. So this will be 6. So ultimately you should be getting, what's the value you're getting? 0.63. Very good. Very good. Very good. You'll be getting 0.63. Now only mathematical portion. This question has been asked with different values in GATE examination for 2 marks. Okay, I thought to discuss, but it's just only calculations part, nothing else. If you see this, it's only calculation, there's nothing. And this is the 17th question. We are left out with 3 more questions. Let's proceed with question number 18. Quick response. 2 masses are attached to 2 ends of a cable which passes over frictionless pulley. Okay, as shown in this figure. You have to tell me what is the acceleration of this 100. Yeah, definitely, Abhishek. You can use Lami's also. It's only for your comfort level. If you're comfortable in Lami's, you can proceed with that. If you're not comfortable in Lami's, no worries. Okay, quick. Let me shorten my video so that you are able to see this. diagram. Yes. So definitely, now tell me which block will be moving upward and which block will be moving downward. If you see the diagram, I know this is a very silly question, but still you need to respond in order to solve this question. 100 kg will be moving downward, 50 kg will be moving outward with some acceleration A. So I can say this will be 100 G, that is 100 G minus tension T is equal to 100 A, and T minus 50 G is equal to 50 A. Add these two equation. So we'll be having 100 G minus 50 G is equal to 150 A. So we'll be having 50 G is equal to 150 A. So A is equal to 50 by 150 G, that is equal to G by 3. Tell me the answer, quick. Gaurav has responded correctly and quickly. Very good, Gaurav. Correct answer. Very good, Gaurav. Correct. Very good. Absolutely correct. Option C. Option C. Very good. Very good. Okay. Fine. Correct. And my dear friends, I'm again telling you, there's a pinned message you can see on your mobile phone. There's a Telegram group. There's a mechanical Telegram group. Okay. You will be getting the PDF of this session. Okay, so that you can see when you are practicing the engineering mechanics, you can solve this 60 questions before the examination for complete, we can say, revision of engineering mechanics. Okay, option C is the correct answer. Very good, Sunita, Sonali, very good. Absolutely correct. Next, 19th question. This is the 19th question, my dear friend. We have reached to the second last problem. An ideal spring with a spring constant K is hung from a ceiling and a block of mass M is attached to its lower end. Okay, if mass is released with the spring initially being unstretched, what is the maximum extension of the spring? So basically what is happening, so this is the case. Okay, the mass has been left like this. So there is a mass which is attached to a spring and we are leaving this mass, so definitely it will be elongating. Let us suppose that elongation is this x. So you have to tell me what is this maximum elongation. What is maximum elongation? Tell me. Same energy conservation, my dear friend. Energy conservation. Use energy conservation and get the answer. So the potential energy due to the height of the mass will be equal to the potential energy in the spring. So I can say mgx is equal to half kx square. So from this, can I get the value of x is equal to 2mg divided by k? Simple one-liner answer, option B. Option B, the potential energy of the mass will be equal to the potential energy of the spring. That is a maximum deflection because the mass is kept at a height. So when you are releasing that mass, the spring will be elongated. That elongation of the spring is basically what we are doing. The decrease in the potential energy is the increase in the potential energy of the spring. Okay, so from this you are getting option B is the correct answer, 2 mg by k. 2 mg by k. Is this clear? Fine. All good? All perfect? All good? Enjoying? Please do tell me if you are enjoying, so that in the next class I'll be coming up with more difficult questions, more good level of questions. Okay, so that you are having complete concept clarity of engineering mechanics. If you're mechanical, if you're a civil, okay, please do have this sessions for 3 days. That's it. Engineering mechanics, no need to open any textbook, no need to open any revision, only you need to be consistent for the next 3 days. Okay, last question, 20th problem, I'm giving you as an homework. Okay, what you guys need to do is you need to tell me the answer in the comment section. Okay, you need to tell me the answer in the comment section, and tomorrow I'll be telling you the name who has responded correctly. So make sure you are answering to this problem before 6 or 6:30. Okay, before 6:30 tomorrow evening, and I'll be announcing the names who have responded the answer correctly. and top 5 students, that means those will be responding correctly and quickly, top 5 students I'll be responding. Okay, and if I'm getting time, and definitely I'll be sharing the names of that 5 students. So this is a homework for you guys, so make sure you all are responding in the comment section. Okay, don't respond right now because this competitiveness, so make sure you are giving a tough competition to your friend. Okay, so thank you guys, this is it from my side. This is Sooraj Gopi. I hope you all like the session. And if I talk about the different courses which is live on the Gradeup platform, we are having your Gear Up Gate Mechanical or Rank Up Gate or Vision 2022. So those who want to revise the entire syllabus of the gate, the best course is your Gear Up. If you want to improve your rank, we're having a rank up gate, and those who are preparing for the next year, next to next year, that is 2022, there's an ideal course that is Vision 2022. Okay, and these are the students who have secured top in the top 100 last year, and I want your photograph next year, and your juniors will be seeing your photographs and will be saying these are my students who have secured in top 100. Okay, fine. And about the Gradeup Super, if you're becoming the member of the Gradeup Super, you'll be getting the access to all the courses. The best part, that means subscribe to one and be getting all this. Okay, and grid card, you all guys know that is a mock test, and before examination you only need to attempt the mock test. That's it. So that is from my side. 3 months, 12 months, 18 months, 24 months, these are the cost. You can see on your screen. Best suitable you are feeling, you can definitely opt for this. Okay, so thank you guys, this is Sooraj Gopi signing off. I hope you all like the session, and make sure without tomorrow 7 p.m. guys, 7 p.m. same channel, that is your Gradeup Gate channel. Okay, so let's meet tomorrow 7 p.m. and let's understand next 20 questions along with this homework which I've given you. Okay, so thank you guys, stay safe, stay connected. This is Sooraj Gopi signing off, and good night and all the best for your examination. Bye bye.